We are talking about Chapter 7, and Chapter 7 is all about estimating population parameters, okay? So, key concepts. All right, the first section we talk about estimating population proportions. Now, let's start by what the heck a proportion is. Do you remember? So, a proportion is a sample or not a sample, it's a percentage of some other bigger picture. So, for example, the percent of people that have brown eyes. So the percent would be the proportion. That would be the proportion of people who have brown eyes. In my class, in my statistics class, that could be a sample. In all statistics class, that would be a population. But it's, it's a percentage of something from something, okay? So another example would be the proportion of students that have, I don't know, blonde hair. So that's a percentage of something. If it's a percentage of a sample, it's a sample proportion. If it's a percentage of a population, it's a population proportion. So it's a percentage or a fraction, right, which could be represented in decimal form or percentage form. That's what a proportion is. Now I'm going to talk about proportion because we're starting the chapter, but in all of Chapter 7, talking about confidence intervals in general, you can have it for a mean, you can have it for a standard deviation, and the concept is the same for all of them. What are you doing? So this section presents methods for using a sample proportion to make an inference about the value of the corresponding population proportion. I am using sample statistics to give an approximation or a guess of what would represent the population corresponding to that situation. So what does that mean? In my class, I take a sample proportion of, this is going to be something stupid, but, students that have brown eyes. So my sample proportion is, I don't know, 70%, right, or 0.7. I'm going to do some calculations, use some methods to determine for a population of samples, statistics students, let's say. We're going to use that to approximate the population proportion for the population, how many students in that population have brown eyes, what percentage, and we're going to get a range of numbers to represent the population percentage. So again, I'm using sample statistics to approximate a population proportion or a parameter. Remember, I told you the terminology is going to come back. Sample, statistic, population, parameter, right? Parameter comes from a population, statistic comes from a sample, and then the notation varies dependent on what you're talking about. So that's what this is all about. Using your sample statistics to approximate, you're going to get a range of numbers, and a range of numbers would indicate an interval of numbers where your population parameter would lie. That's called a confidence interval. So that's what this is all about, finding confidence intervals. A confidence interval or an interval estimate is a range or an interval of numbers used to estimate a true value of a population parameter. So what is this range of numbers where the actual population value would lie? So again, if I'm talking about percentage of students with brown eyes, I'm using my sample to approximate it for the population, and I'm going to get a range of numbers to, approximate it. It's going to be somewhere within that range, and that's called my confidence interval. It's all about finding this. We start with proportions, and we go into means, and we go into standard deviations. A point estimate is a single value that is used to estimate a population parameter. So, so what do I mean? Well, is my thing on? Obviously, if I'm going to approximate a population proportion, I'm going to use a sample proportion to approximate a population proportion, right? I'm not going to say, the percentage of students that have brown eyes and use that to find, an average. Okay, so we're kind of like, so what I mean by that is, in notation, a point estimate is what you're using from the sample. So p hat is a sample proportion, is used to estimate P, which is a population proportion. And then, of course, they have to correspond to similar things. You'll see as I go through. X bar is a sample mean. which is going to be used to approximate a population mean, mu. Remember, these are symbols that we used before. They're coming back. S, a sample standard deviation, is going to be used to approximate a population standard deviation. And these guys, these sample things, these are the ones that are the point estimates, per situation. So that's what a point estimate is. I'll show you an example as well, but we talked about a confidence interval. A confidence level is the probability 1 minus alpha, we saw alpha before, we're seeing it again, that the confidence interval actually does contain the population parameter, assuming that the estimation process is repeated a large number of times. This is also called a degree of confidence or a confidence coefficient. How confident am I in that interval of numbers that contain the potential true value of the population parameter? So, you'll see typical, let me move this down, typical confidence levels. You're going to see repeated ones. You're going to see a confidence level of 90%. This is a typical confidence level used. And if your confidence level is 90%, your alpha is always 1 minus the confidence level, right? So you're going to need to know how to find alpha. So if you have a confidence level, alpha is always 1 minus that. So alpha in this case would be 0.1. So alpha and the confidence level go hand in hand. Another typical confidence level is a 95% confidence level. Alpha is the complement of that. I could find my alpha, right, by doing 1 minus the confidence level. So my alpha here is 0.05, right? These are typical confidence levels you're going to see often. That's a 5. That looks like a 3, but it's not. 99% confidence level, where alpha would be 1 minus 0.99 or 0.01. Okay, so these are 3 typical, they're not the only ones, but they're typical confidence levels. So if I have a 90% confidence level, then I am 90% confident that my interval that represents my true value of my population parameter, I'm 90% confident that it does in fact lie in that interval. I'm 95% if it's a 95% confidence level. I'm 95% that interval that I have actually does contain the true value of whatever parameter I'm dealing with. That's what this is. And then I'll bring up the words again. Critical values. We talked about critical values before. It should seem familiar. Let me bring this to the next page actually. I might practice finding a critical value before I do anything else. Okay, critical value is the number on the borderline separating sample statistics that are significantly high or low from those that are not significant. Z of alpha over 2 is a critical value that is a z-score with the property that it is at the border that separates an area of alpha over 2 in the right tail of a standard normal distribution. So we've seen this notation before. We just haven't seen it as z of alpha over. We've seen this notation. We talked about it in chapter 6. This was a specific z-score with this little area in the right tail. We need to know how to find, and I used the term critical value before. We need to know how to find critical values. This is a z-score, right? So if it's a z-score, I'm automatically on an SND curve, right? I'm automatically, mean is 0, standard deviation is 1 for this particular value. So let me just start first by finding critical values, because you technically know how to find them, but I'm adding something else because now you're taking it from a confidence level. So if I ever write CV, critical value, if I ever write CI, confidence interval, if I ever write CL, confidence level. So I'm going to use my abbreviations now. Confidence level, confidence interval, CV, critical value. We're going to start just here. Let me take an example from your book, actually, and use that for this. Real quick, hold on. Okay. I'm not going to do all of these, but I'll do maybe 1 or 2. So Find the critical value corresponding to the confidence level. They give you a confidence level and you need the critical value that corresponds to that confidence level. So let's start with, number 5. You guys technically already know how to do this, but you might not know that you already know. Your confidence level is given for number 5 as 90%, right? Find the critical value that corresponds to this confidence level. Critical value is this notation, z of alpha over 2. So that means you need to know alpha to find the critical value for your situation. How do you find alpha if it's not given to you? It comes from the confidence level. Confidence level is 90%. Alpha is the complement of that. 1 minus 0.9. So alpha in this case is 0.1. Okay? That's going to go here. But alpha over 2 is the area that I'm referring to. You're kind of splitting it into 2 pieces. So I'm going to calculate alpha over 2 first. So 0.10 is alpha. I'm going to divide that by 2. So that is equal to 0.05. Now, I want z of alpha over 2, or z of, in this case, 0.05. So we've done this notation before. This is a z-score. That is a horrible straight line. This is a z-score, which means it's on a normal distribution curve, a standard normal distribution curve where the center is 0. And I want to find the z-score with this little area in the right tail. This is the value here that separates this area from the rest. This is my critical value. How do I find a z-score if I know an area? Well, back in chapter 6, what we do, normal CDF or inverse norm. Well, which one finds the critical value? Which one finds the z-score if I know the area? Normal CDF or inverse norm? Inverse norm. And when you do inverse norm, you always remember you're doing the area to the left, right? Well, do I know the area to the left? No, I'm given the area to the right. How do I find the area to the left? 1 minus the area to the right. So I said, when you input that into your calculator, you could directly just put 1 minus point. You don't have to actually calculate it if you don't want to. Well, let's pull out my calculator and do that. Okay. So how do I find inverse norm again? So second, bars, right? We want to pull up distribution down to inverse norm number 3. Enter. Mine shows up like this, right? If it doesn't show up like this, you put area to the left, mean and standard deviation. Area to the left is 1 minus 0.05. Mu is 0, standard deviation is 1 because I'm talking z-scores, so I'm talking standard normal distribution curve. Right? I am always going to keep it left so it stays consistent with everyone. This is what it looks like if you guys don't have the fancy calculator. It doesn't have this part. 1.64. Now, sometimes you're going to take 2 to the right of the decimal. That's typical for a z-score. And then for some of these special critical values, you take 3. So 1.645 if I round to the nearest 3 digits. So 1.645 is the critical value in this case, or approximately. 1.645 is the critical value that corresponds to a confidence level 90%. That is the value here that's on the borderline, separating all the sample statistics that are significantly high or low that are not. I mean, you see that you divide alpha by 2, so technically you have critical value over here, but it would be the negative version of this. But we're always going to take the positive version because in our formula, it already takes care of positive and negative cases. Technically, we're dividing alpha into 2 pieces, but we're always finding the positive version of it. I'm going to do one more. For number 6, find my 99% critical value. I'm given a confidence level that is 99% confidence level. My critical value is z of alpha over 2. So again, I need to know alpha, right? And if I'm not given alpha, I look at my confidence level. And alpha is always 1 minus my confidence level. So in this case, 0.01 is my alpha. This says z of alpha over 2. So I'm going to cut that in half. 0.01 is alpha, divided by 2 is 0.005. So technically, I want z of 0.005. This is the critical value I'm looking for. And this notation we saw in chapter 6. It is a z-score. And given that it's a z-score, can't draw a straight line. That means it's on a SND curve automatically, right? The center is 0, the mu is 0, standard deviation is 1. And this is a value. We're going to find the positive version, right? We cut it in half. So we're going to go into the right tail. That area in the right tail is 0.005, and I want the critical value, which is the value here, the z-score, separating all of these from this. And if I want a z-score, if I'm given an area, I use inverse norm. Again, I'm given the area to the right, so I always do 1 minus, right, to get the area to the left, because every time we do a z-score, inverse norm, we always want the area to the left of the value that we want. Second, bars down to inverse norm. I don't know how many times you guys have already done this. 1 minus 0.005. Just be careful with your decimals. Mean is 0, standard deviation is 1 because I'm on an SND curve. 2.576. Rounded to the nearest 3 digits. 1,000. What I say, 2.576? 2.576 is the critical value that corresponds to a confidence level of 99%.